Hello. Is it audible, right? Hello. Right, Nana. So last class what we are discussing now? Right, Nana. So ortho-para-directing groups, right? For example, if benzoic acid is there now. Okay. See, Nana, this is a benzoic acid. This is a withdrawing group, right? Electron withdrawing group. So this is taking the electrons from the benzene ring. Yesterday I explained, right? So what exactly happens in this case? CO minus OH is the positive charge is coming down. Write it down. Next, Nana, if this electron is going over here, what exactly happens? Huh? Yeah, it is the double bond, positive charge, CO minus OH. Yeah, so here is double bond, yes. It is the double bond. Next, huh? So this is coming like this. Yeah. So here is the positive charge, and so what exactly happens? CO minus double bond OH. The last step, what exactly happens? Back. So C double bond O OH. Right now. These are the resonating structures we will get. Write it down. Very important. At ortho and para positions, Rana. At ortho and para positions, C double bond O OH. Which charge is coming? Positive charge. So if electrophile is electrophilic substitution, right? If electrophile is coming, so it is attacking at which position? Obviously at meta position, because at ortho and para positions already electron deficient is there, so it can't attack over here. Positive charge, positive charge. So electrophile is attacking at meta position. Write it down. Meta directing. Hello. Okay. Mute lo beta. So now is it audible? Ra? Okay. So this is a electron withdrawing group. At ortho and para positions, positive charge is coming. Ra. So benzene undergoes electrophilic substitution reaction. The electrophile attacks at right meta position. So meta directing groups are like that. So detailed we'll discuss in the second year classes. Even in case of nitrobenzene also the same thing is happening. What exactly happens in case of nitration? One thing. చేసావా nitration ది? So the resonating structures we did it. Okay. Right now. So these are the main thing is benzene undergoes electrophilic substitution. If any donating groups are there, right? At ortho and para positions, negative charge means electron density is increases. So if the electrophile is attacking when the donating group is present, at which positions, Rana? Ortho and para positions. This is a final thing. If electron withdrawing groups are there, electron withdrawing groups are there, so it attacks at meta position because at ortho and para positions already positive charge is coming. So yesterday I told you, so JEE means the question came from over here. So for example in D place, methyl group is given, here is some COOH, NO2, COCH3 like these groups are given, right? So which of the following is a more electrophilic substitution reaction is takes place? So which one? These three are minus M. Ortho at para positions, what happens? Positive charge is coming. But the CH3 at ortho para positions, negative charges. Electron density is more at the same question yesterday they asked in the JEE mains. Okay, one of the important key concepts, write it down. Because I explained the resonating structures and all. Done? The phenol and aniline reactions are there. I'll explain those in the second year because 11th class guys are there, so people won't understand. So then next put the heading nucleophilic substitution reaction. So nucleophilic substitution reaction. For example, Rx nucleophile, right? Rnu plus X minus. So nucleophile is substituting here. Nucleophilic substitution reaction simply. Alkyl halides, for example, CH3CH2 Cl. For example, OH minus, aqueous KOH, right? Aqueous KOH. So what exactly happens? CH3 CH2 OH. So nucleophile, this is acts as a nucleophile. Nucleophilic substitution reaction takes place. Here is one important reaction, Nana. So once again, this reaction we'll discuss in alkenes also. CH3CH2Cl. So if we are using the aqueous KOH and alcoholic KOH, alcoholic KOH means solvent is water here, solvent is alcohol. So here nucleophilic substitution reaction takes place. CH3 CH2 OH. This is alcoholic KOH, we are called as dehydrohalogenating agent. So CH2 double bond CH2. So elimination reaction takes place. This alcoholic KOH we are called as what? Dehydrohalogenating reagent or dehydrohalogenation takes place. In this case, nucleophilic substitution reaction takes place. So write it down. In nucleophilic substitution, SN1, SN2, SNI, 3 types are there. So those I'll explain in the second year. So this reaction we can use in the preparation of alkenes. The preparation of alkenes. So which reaction? This is elimination reaction, right? Elimination reaction. Elimination reaction. In elimination, E2 reaction takes place. I'll explain that. This is elimination. Dehydrohalogenation takes place. HCl is going on. HCl is going on. Okay. Next, put the heading free radical substitution reaction. Free radical substitution reaction. So free radical substitution reaction takes place in where? Alkanes. Write it down. Alkanes in presence of sunlight, H nu. So here is a chain reaction. First we'll get CH3 Cl plus HCl is going out. One Cl is substituting. Free radical substitution. Free radical means Cl radical is replacing with. Once again, if CH3Cl is treated with one more Cl2, Nana. Same sunlight. CH2 Cl2 plus HCl. Once again, CH2 Cl2 plus Cl2 HCl, right? What will get? CH Cl3 plus HCl. Next, now this CHCl3, the Cl2, PCl4 plus HCl. So write it down. So what we did in case of here, 4 hydrogens are there. We just keep on removing one hydrogen in the first case. Here we removed one hydrogen. In this case, 2, 3, 4 like that. Got it? Once the reaction is started, so it's a chain reaction. So here we can't replace because total hydrogens are replaced here, right? We'll see its mechanism. The first one is mechanism we'll discuss. ఏమవుతుందిరా? ఎంతమంది వచ్చాము? Done? So mechanism is important here. The first reaction mechanism I am explaining here. So for example, CH4 plus Cl2, sunlight, right? CH3 Cl plus HCl. For this, I am just explaining the mechanism. First, so we could say chain initiation. First step, we could say chain initiation. In chain initiation, what exactly happens? This chlorine, Cl2 undergoes homolytic cleavage. 2 Cl radicals are forming. Homolytic cleavage means I told you, right? Equal cleavage. 2 Cl, Cl, right? For example, homolytic cleavage takes place like this. Homolytic cleavage takes place. 2 chlorine radicals. This is in the chain initiation. Next, in chain propagation. Chain propagation. This chain propagation step is important, Nana. So in chain propagation, first this CH4 and one Cl radical is coming from over here. What exactly happens? CH4 undergoes homolytic cleavage like this. CH3, H. CH3 radical and H radical. That H radical combined with Cl radical. CH3 radical is forming plus HCl. H radical is coming from over here and Cl radical. This H and Cl combining HCl. Now once again this CH3 radical, one more Cl2 we are taking here. So here we will get CH3 Cl plus Cl radical. The Cl radical once again going back to methane, right? This total process, these 2 steps keep on propagating. And for example, we are starting from one place to other place. We just started the bike. Here is started. This is propagation. Propagation keep on taking. So total vibration is coming. So propagation step takes place. Next, last step, chain termination. chain termination. In chain termination, for example, two chlorine radicals are remaining. Imagine Cl radical plus Cl radical will get Cl2. For example, one CH3 radical, one Cl radical is remaining, CH3Cl. For example, one more CH3 radical, CH3 radical, CH3. So these are forming in a trace amounts, but we won't consider. So the major step is chain propagation step, right? Chain initiation, chain propagation, chain termination. This is very important. Just write it down. In alkanes topic in the 11th class it's coming. In alkanes it's coming, so write it down. Initiation, propagation, and termination. So more important is chain propagation. They keep on asking the questions from chain propagation. Write it down. Done? Where that is? ఎక్కడ అవి దాంట్లో అవుతున్నా యాన్యువల్ డేనా ఇప్పుడు యాన్యువల్ డే ఏంటి నెక్స్ట్ అన్న ఫర్ ఎగ్జాంపుల్ CH3 CH2 CH3 plus Cl2 sunlight. So we know how many types of carbons here? How many types of carbons? This is 1 degree. This is 2 degree. This is 1 degree. So if the chlorine can attack either here or here, two options are there. So if it is attacking primary carbon, for example CH3, CH2, CH2, Cl, 1 chloropropane, 1 chloropropane plus 2 chloropropane is also possible. Two chloropropane is also possible. 1 chloropropane, 2 chloropropane. But how much product, how much percentage of product is 1 chloropropane is forming, how much percentage of 2 chloropropane is forming? How should we know? Chlorine is more reactive, less selective. Write one statement. Chlorine is more reactive, less selective. More reactive, less selective. But bromine is opposite, Nana. Write it down. Bromine is what? Bromine is what? Less reactive, more selective. Reference integral అనుకోండి, right? Whenever you are going to home with hungry, right? So do you ask, what do you ask your mother? Food, is there any food? Yeah, whatever it may be, just okay, let me, I am ready to eat. Just, right? No selective. You already ate something with friends outside, biryani, something else, and you went home, right? Your mother, right, asked to eat something. So you would, that time you are more selective. So what is special today? For example, something, lady's finger or something else. No, I don't eat the lady's finger. If you would like to prepare biryani for me, I'll eat, right? That is more selective. If you will do the biryani, then only I'll eat. That is about bromine. Chlorine case, nothing. అంటే ఏంటి, మీరు బాగా ఆకలితో వెళ్ళారనుకోండి, రైట్, ఏది ఉంటే అది పెట్టేసి, మస్తు ఆకలి, మోర్ రియాక్టివ్, లెస్ సెలెక్టివ్. ఏం లేకపోతే కనీసం పచ్చడిని వేసేసి పెట్టేసి అని తినేస్తాం. నో ఇష్యూస్. ఫుల్ ఆకలి అవుతుంది, కడుపులో ఏంటం ఎలకలు పరిగెడుతున్నాయి. వెరాజ్ ఇన్ దిస్ కేస్ మీరు మంచిగా తినేసిపోయారు, లెస్ సెలెక్టివ్. ఏం కూర వండినావు ఈరోజు? వద్దు, నాకు బిర్యానీ చేస్తేనే తింటా, లేకపోతే తిన్నా, అంటే లెస్ సెలెక్టివ్. ఐఎమ్ నాట్ స్పీకింగ్ అబౌట్ ద బ్రోమిన్ రైట్ నౌ. హియర్ ఇస్ chlorine. So 1 degree, 2 degree, 3 degree cases. So the chlorine, how much percentage we need to know this, no? For example, 1 degree case, this is 1 we will take. For 2 degree cases, 3.8. 3 degree case, it's 5. 1:3.8:5. Write it down. 1:3.8:5. Means this is 1 degree, 2 degree, 3 degree case. In substituting in 3 degree case, for example, to percentage, if you will take 100, so 5 will go for the 3, and 3.8 will go to second degree, and 1 will go to the primary. But whereas in case of bromine, 1 is some 82 is some 1500, some like that. So it means more tertiary. So 1 is to something 82 or 92 is something 1500. Approximate what I am telling. So this much of variation is there. So actually it's not needed. So just write it down. But based on this ratio, we are going to tell which is major and which is minor percentage. Now let me know, in this case, how many primary hydrogens are there? Hello? How many primary hydrogens? Primary carbons are 2. How many primary hydrogens? Total 6. 6 possibility is there. Any hydrogen can replace with the chlorine. 6 into primary hydrogen means what we need to take? 1. How much now? 6. How many secondary hydrogens? 2. 2 into 3.8. How much? 7. 3.2 into 3.8. 7.6. Total is how much? 13.6. Yes or no? In case of primary case, so how can we say the percentage? 6 by total is how much? 13.6 into 100. This is 1 chloro. In case of 2 chloro, 7.6 by 13.6 into 100. Let me know the answer. Here is how much, there is how much. Approximately we'll get here is 45%. Calculate it. If you can use the percentage, no need to by heart, so directly we can do like that. 6 by 36 into 100. 6 by 36 is how much? 44. Approximately, okay, 45%. This is 55%, like this. Almost all near 45, 44, like that. Got it? How to calculate? Do it, write it. Done now? Next, try this now. Write the products. How many types of hydrogens are there? Write it and let me know the products. Come on, do it. హలో, జాయిన్ అవుతున్నారు వాళ్ళు? నేనా? నేను లేదు. How many types of carbons here? This is 1 degree. This is 1 degree. This is also 1 degree. This one, 3 degree. So 2 possibilities are there. Anywhere if you are attacking, no issues. You will get CH3, CH3. For example, if tertiary case 1 compound, and one more is CH3, CH3, CH2Cl. Let me know the percentage. Two cases, let me know the percentage. $64. This is this is how did you do this? Total here is how many hydrogens? 9, right? 9 into 1, 9. 5 into 1 into 5. 5, 14. Right, here is 5 by, here is 5 by 5 by 14 into 100, right? How much you are getting? This is how much you will get? Here is 9 by 14 into 100. Percent, 5 by 14 into 100 is 36, huh? This is 64%. Got it? How to do that? Okay, now? So shall we do one more? So make now. Guys, do this. Come on, do the products, write the products, and let me know the percentage. Done, completed. How many hydrogen carbons are there? How many, which type of carbons here? This. So, these are 2 degree, 2 degree, right? So, no issues. You get the same type of, right? CH3, CH, for example, Cl, CH2, CH3. And in this case, CH2Cl, 1 chloro, butane. Right? 2 possibilities are there. Let me know total how many primary hydrogens? 6. 6 into 1, 6. And 4 into 3.8. 15.2. Total 21.2. 21.2. Right? So here is 15.2 by 21.2 into 100. 72% of. So exactly 6 by, here is 6 by 21.2 into 100. Here is 28%. Free radical substitution. Like this, they'll ask the questions, and nitration, sulfonation, this type of questions are there. I'll discuss in alkanes topic. Next, Nana, elimination reactions. Elimination reaction. Elimination reactions are 2 types. What are those? Alpha, beta. Beta elimination, once again, we are going to classify 3 types. E1, E2, E1CB. Write it down. Elimination are 2 types: alpha elimination, beta elimination. Done? What is alpha elimination? Alpha elimination. In case of alpha and beta, so alpha elimination means what? For example, take one example like this. CHCl3, nothing but chloroform, right? In case of beta elimination, we are removing from the adjacent carbons. So here is hydrogen and chlorine, H plus and Cl minus. We are removing from the same carbon. Only one carbon is there. CCl2 we will get. This is. So here is one lone pair in dichlorocarbon. This is dichlorocarbene. Alpha elimination means what? Right? We are removing the 2 atoms or ions or atom, whatever it may be, from the same carbon. If we are removing from the adjacent one, this, right? This is called beta elimination. Write it down. This is beta elimination. Alpha, beta. Alpha means from same carbon, we are removing the groups, whereas in case beta elimination, from adjacent carbon. Adjacent. Write it down. Alpha elimination, beta elimination. Of course, in the both the cases we are using base. Base will obstruct this H plus and Cl minus is going out. Cl or whatever the, not only Cl here, we can take any leaving group. Any leaving group. This one, chloroform, we are using in Riemann-Tiemann reaction. In Riemann-Tiemann reaction, for the second year guys, what I am telling, what is the electrophile? In Riemann-Tiemann reaction, what is the electrophile, they'll ask. So, dichlorocarbene. The dichlorocarbene, how it is forming? By alpha elimination. What is alpha elimination? We have to remove from the same carbon atom. Write it down. Hello. So, I am not explaining there is alpha, beta and gamma and nothing. Okay. Right now. So, these are the generally types of reactions. Rearrangement reactions, those are not needed right now. So, we are not. So, addition reactions we discussed. Addition, three types: electrophilic addition, nucleophilic addition reaction, free radical addition reaction, substitution, electrophilic substitution reaction, nucleophilic substitution, free radical substitution, elimination reactions, right? Alpha, beta, so like that only. So, beta once again E1, E2, E1, CB, that we will discuss later. Okay. Next class will start with the hydrocarbons, right? Hydrocarbons, hydrocarbons means hydrogen and carbon. Hydrogen, carbon we call as hydrocarbons. Particularly here, first we'll discuss alkanes, CN, H2N plus 2, alkenes, CN, H2N, alkynes, CN, H2N minus 2, CN, H2N minus 2. So, then afterwards we will discuss aromatic compounds, benzene reactions, the preparation of benzene and all. So, I will start this hydrocarbons from Monday onwards freshly, because if I am starting here, so it's only 5 minutes. I will start this hydrocarbons from Monday onwards. So, freshly we will start. Okay. So, now Monday నుంచి స్టార్ట్ చేద్దాం రాబోయ్.